Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhaumik, and in this lecture series of Special Theory of Relativity, we are covering length contraction today. So just like time dilation, length contraction is also a consequence of Special Theory of Relativity. And here let us consider an axis. I am drawing only the x-axis, I am not showing the y and the z. This is x-axis, and let's say there are 2 points. This is my, let's say there are 2 points. This is x1 and this is x2. This is x1, this is x2. And let's say another frame. Let's say another frame. This is x1 dash and this is x2 dash. What is x1 and x2? Let me assume a rod. There is a rod whose length in the initial frame is L0, and here the rod's length is L dash, or let's say L, only L. Now we can say the length of the rod in this frame is x2 minus x1, and this frame we can write x2 dash minus x1 dash. Now this frame, let me name it as f1, let me name it this one as f2. This f2 frame is moving with a speed of v with respect to f1. F2 frame is moving with a speed of v with respect to f1. So that is, now let us see how can we apply our, so now let's see how things are happening out here. So we had, let me write out once again, L0, that was the initial length at rest, that is x2 minus x1, and L we were having x2 dash minus x1 dash. See, our formula for x for Lorentz transformation, we can say x, that is gamma into x dash plus v into t dash. So we can write L naught. What is gamma? We know gamma is one by root over of 1 minus v squared by c squared, where v tends to c, gamma tends to infinity, and when v tends to 0, gamma tends to 1. So now L naught is equal to x2 minus x1 is equal to, what is x2? x2 I can write gamma x2 dash, since x2, this is a moving frame, x2 dash plus v into t2 dash. This time won't be same, minus what, x1 dash minus v into t1 dash. See, t dash and t2 dash are not same. T dash and t2 dash are not same. Now what we can write here, I can take gamma common. X2 dash minus x1 dash minus again gamma into v common, t2 dash minus t1 dash. See, one thing I can say here is that, remove this, what we can say, t1 dash is not equal to t dash because they are in a different frame of reference, moving, uniformly moving. But I can definitely say that t1 dash will be equal to t2 dash because these are corresponding to the length of the rod, the position of the rod at the same time. T1 dash and t2 dash are corresponding to the time corresponding to the length of the rod at the same time. That is the rod, that is, it is a t1 dash and it is a t2 dash, that is at the same time it is corresponding to at the moving frame, that is f2. So I can write t1 dash is equal to t2 dash, so this term will become 0, and this is L naught, and this one I can write as LL. So the final expression what I can get here is L naught is equal to gamma into L, implies that L will be L by gamma. L is equal to L naught by gamma. Okay, now what is one gamma? Gamma is my, I can say, one, this one I can say, that is gamma is 1 by root over of 1 minus v squared by c square, and this is something which is greater than 1. So 1 by gamma will be less than 1. So L will be less than L naught, and this is the length contraction. So Let me give you an example. There is a spaceship. The length of the spaceship is some 100 meter. It is moving with a speed of, let's say, 0.6 c. It is moving with a speed 0.6 c. What is the length of the spaceship with respect to an observer who is outside? What is the new length? L dash. So we can write L dash is equal to 100 by gamma. What is 100 by gamma? 100 into root over of 1 minus 0.6 by 1 whole square, because v square by c square. So 0.6 by whole square, that will be 0.8, that will be 80 meter. To an observer here, he will observe that, he or she will observe that it is 80 meter. That is the phenomenon of length contraction. So that's all for this lecture, and if you like our content, then please subscribe to our channel and click on the bell icon.